Good morning to all of you. I am Professor Mariappan, Department of Marine Engineering. Very nice to meet you everybody through this session. Regarding, we have to discuss about in this class a momentary look of CED. First of all, I want to tell the information regarding the CED, that is corrosion engineering doctoral. So the definition for the corrosion engineering doctoral, that is nothing but a person who is involving those who are controlling the corrosion is called as a corrosion engineering doctoral. Okay. So this most probably the factor of involvement is applicable in oil and refinery industries. So in the oil and refinery industries, most probably in the expected information, expected and anticipated role of activities is corrosion. So wherever, even from a bolt nut and washer to any classification of the equipments that can be controlled by means of certain engineers to identify what type of the corrosion that has been affected by the material. So the information regarding the corrosion is the very serious factors to control for the equipment from the corrosion. So the factor of safety, FOS, can be retained by the equipment at the time of the manufacturing. What is the same that can be, we cannot be maintained throughout the life of the equipment, that may be varying, but even though we can say that the corrosion is a medicable, that is the mandatory to control a measurable factor. So is a very applicable oriented class for the corrosion controlling and corrosion engineering doctor. That's why the engineer is called as a doctorate. How the doctor give a treatment for the patient, like here the patient is the equipment. Now the equipment is affected by means of a certain corrosion. So engineer, now he is become as a doctor, he control the corrosion. That's why he called as a corrosion engineering doctor. Main objective of the corrosion engineering doctrine, that can you see what are the types, what is the corrosion and classification. Maximum corrosion, we can say, is affected by certain mechanisms. So corrosion mechanism and classifications. Corrosion prevention method is the medical measures. Okay, so these are the main objective. And corrosion is the life factor. If you are saying as a corrosion is nothing but a material is affected certain chemical reaction or electrochemical reaction. Among these two different factors involved in a material, the material will be affected and the life factor will be reduced. If the life factor is reduced, means it lost the property. The material, it loses its property to work in the same range or same. Range means here certain pressure, certain temperature and chemicals. So all the engineering equipments in the industry, especially for the oil and refinery, petrochemical, fertilizer, chemical base, these are all having different variety of the equipments, different name of equipments according to the nature of the process. The process is the process fluid is flowing with a chemical compositions. So separate engineering departments functioning for the process engineering. That process fluid is flow inside the equipments. Equipments categories, if you are saying as a exchanger, heat exchanger, HE, shortly it is called as a HE, heat exchanger, PV, pressure vessels, BV, boiler and pressure vessels. So the materials is converted in the form of equipment. The equipment involved with the chemical reactions by means of the flow of fluid, process fluids. That's why the process fluid affect the material with certain temperature, certain pressure. So the major role involved in the industrial is pressure and temperature. Low pressure, low temperature is the certain category of the material with equipments functioning under the process fluid, and higher temperature, higher pressure, that is the different, is the ultimate higher level of equipments like as a boiler, incinerator, reformer, reboiler. So these are the high temperature, high pressure with high velocity. So the velocity also one of the another factors involved for the corrosion. So the corrosion is defined as an adventitious constitution of a solid body by chemical or electrochemical reaction starting from the surface. Okay. So if chemical reactions, say as carbon steel is CS, carbon steel react with oxygen, the ferrous oxide is the corrosion factors. Now how it created? Because of is generally now is the open atmosphere. All the carbon steels, say as from our home window door made by steel, carbon steel. How we say that carbon steel ferrous content is the more. 99% of the content is the ferrous. So if it is that, then the metal is called as a ferrous material. The ferrous material, if it is openly contact with the oxygen is contact with ferrous oxide is the chemical reaction, is a form of corrosion. So it is called as a rust. So we are saying is a commercial name as a rust, is a reddish color or brownish color, but its technical name is called as corrosion. If it is a surface level, that is called as a superficial corrosion. If it is a very deep, then it is called as a surface corrosion. The corrosion name is varying depending upon the level of contaminations. So that is the introduction. In the corrosion, contact with oxygen or hydroxide, carbonate, sulfide. So these are the main role of the chemical reactions taken along with the material. The material will be degraded and it will be converted, lost its natural property. The chemical reaction reduce the life of the material, hence the life of the equipments also reduced. So how to retain the life of the equipment for a prolonged duration of year, because of the very huge expenses how to face for the manufacturing of equipment. For example, a heat exchanger. A number of components, around 41 number of components are there in the heat exchangers. The 41 number of components, if it is damaged by means of a corrosion, then we have to go for a replacement of the equipment. We will need a very high expenses. So how to avoid, how to minimize the these kinds of the degradations by means of one engineering department. That engineering department is especially functioning for corrosion engineering doctoral. That is the separate function is comes under NDT. Non-destructive testing is one of the main key role factors for the engineering to medication of measures to control the corrosions. So that is the introduction point of the corrosion engineering doctoral. The definitions, that is the degradations. Okay, mainly metallurgical changes. The metallurgical changes is the degradations. All the materials, we can't be say that which materials comes under degradations. This is not comes under degradation. We cannot be classified. But even though some standardizations say as engineering materials, engineering metals classified in 3 categories only. That is only CS, carbon steel, and another one is SS, stainless steel, and another one is AS, alloy steel. So all the engineering material will comes under these three categories: carbon steel, stainless steel and alloy steels. So naturally degradation and deformations or deteriorations will be mostly affected on the carbon steel material. The carbon steel material, how the engineering materials are classified, at what basis? That is nothing but as per the ASTM, American Standard of Testing Materials. So that is their separate departments functioning for the classification of material comes under the ASTM. So if you are going through the ASTM, is the separate department is functioning also under the entity. They classify these engineering materials in three categories: CS, AS and SS. The CS, that is comes in A classification of material. So A, SA, if the letter is denoted SA, is go for carbon steel. For example, SA516, that is the carbon steel plate. SA106, that is a carbon steel pipe. So the classification of the material is also comes in the corrosion engineering to control by means of certain measurable medications will minimize we cannot be 100% stop the corrosion. It is not possible, but we can mitigate the corrosion and minimize the corrosion from the deteriorations. Due to corrosion, automatically the equipments will comes under deteriorations or destruction or degradation of material. So this can be avoided by means of corrosion engineering doctrine. So that is the major role of corrosion engineering doctrine. That point of information we have to discuss about in this class. Okay. So the chemical and electrochemical reactions, I told you, chemical reaction mostly applicable for the non-metals, and electrochemical reaction is for the metals. Generally, metals and non-metals is the general category of material based on the engineering materials. Okay. So chemical reactions and electrochemical reactions. Chemical reaction also involved in the ferrous and non-ferrous material, but usually the chemical reaction involved in the non-metals, say PTFE, polytetrafluoroethylene. That is one of the material. Is a non-metal. Plastic is a high temperature, high pressure withstanding material. PTFE, highly corrosive absorbing material. That is the PTFE. And PVC, say a symbol, TF, Teflon plastics. These are the materials will be affected mostly by means of chemical reactions. But metals, say as carbon steel, alloy steel, stainless steel, and some other high grade materials, titanium, molybdenum, zirconium. So these are the materials mostly affected by means of electrochemical reactions. These corrosions, due to the reaction, two main types of the corrosions will be occur on the any types of, whether it may be a electrochemical reaction or a chemical reaction affected material will be comes under these two category of corrosion classifications. One is the dry corrosion and another one is wet corrosion. In this case, dry corrosion, that is name itself give you information first, as the dry means here wet is here there is no any moisturous content. Wet corrosion is the moisturous content. So the dry corrosion occurs when material exposed to the gaseous environment. There is no any evaporations. There is no any moisturized evaporations. Then it is a dry corrosion. Productive film, natural film form, the ionic conductivity of the film. So these are the environmental natural to form the dry corrosions. So dry corrosion is comparatively very less severe for the degradation of the material. So it can be partially acceptable, but as a doctoral, corrosion doctoral, you have to roll to minimize from the dry corrosion also. There is one formula, that is the Bedworth formula, that Bedworth rules also how much volume of oxide formed on the material by out of consumed during the oxidation, volume of metal consumed by the oxidations. So there is one formula is applicable to get a ratio number of material degradation. So that is the Billing and Bedworth rule. So from this ratio, say as 100, that is there is no any corrosion. If it is 99, the value have some superficial corrosion. That is some rust formations. Supposed to be 40, the value gives here number 40 figure. That is the very that means more than 50%. It crossed the level. 40 number gives the crossing of 50% of the material degraded. That means 60% of the material outages and 40% is only remaining withstand property and hold it the property to use for the service. Then we have go for some remedial actions. So that is the information we have to get it by means of this formula. Okay. The formation, absorption, chemical absorption, Crope film and porous and non-porous films. Usually porous and non-porous, these are the structural condition of the material. Porous, very often gap between the structural bondings. Non-porous, very tight bonding. So there is some difference. The corrosion easily will occur on your porous materials because of the gap is in between the bondings. Whether may be a PCC or FCC, there is nothing but don't worry about the face of the material property. Even though porous material have a higher property mechanism to absorb the corrosions. For the non-porous material, the bonding between the two atoms have a very lesser. That's why the lesser action of growth on the corrosion environmental in that material for the non-porous material. So wet corrosion, the salt, acid, alkali and electrolytes dissolves ion with the electrons, deformations and non-equilibriums, phase changes from original to change of totally degradations with the decomposition of reactions. So the decomposition due to the swelling of material. Swelling, it seems to be not from the original structure. The structure will be varying layer by layer of coating, like as a coating layer of layer formed on the corrosion. Usually salt solutions, water, cooling water. When you are saying as a cooling water, that is the aqueous electrolytes, that is dissolves the metal ion and electron will be generated. That electron ion oxide, that iron oxide is converted between merge with the two successive iron oxides, create a pitting corrosions. So that is a wet corrosion. Pitting corrosion, one form of a wet corrosion. The pitting corrosion joined together by means of, that is a corrosion, subsurface corrosion will be occurred. If subsurface corrosion is occurred, then a layer of layer corrosion will be developed in between the top surface and bottom surface of the metal. So we can't say that if you are saying seems outside looking very good, but the inside the layer of material degraded and swelling of material is the result, we can get a very severe condition. Yeah. Patch by patch layer of fallen decomposition of material will be fallen if you are hammering. So this is the wet corrosion, very highly danger, and the lifespan of a metal will be very quickly reduced. So comparatively wet corrosion and dry corrosion, wet corrosion very often danger. The mechanism of the wet corrosion, hydrogen evaluations and oxygen absorption. So these are the two main factors for the mechanism of the wet corrosion. Hydrogen Hydrogen is also available with the atmospheric air. Oxygen is also available with the atmospheric air. So the ion, if it is open to atmosphere, they exposed to atmosphere, easily it will be absorbed and receive the hydrogen or receive the oxygen. The ferrous oxide, ion oxide, it will be converted in the form of ferrous oxide to create a surface corrosion. That is one form of a wet corrosion. Here the nature of the air having a moisture, this moisture is along with hydrogen and oxygen. So that is the factors, that is the anode factors and cathode factors. If it is emits the electrons, if that is the anode, if it is emit the electron with hydrogen, that is the cathode. That's why the corrosion engineering cathode production, cathode is, anode is a inside the chemical compositions, it will be occurs inside the equipments. Cathodic production usually open with the atmosphere. So that's why any process piping or highly corrosive nature of equipments protected by means of cathodic productions. So that is a separate engineering departments also comes under CDE, corrosion engineering doctoral, that is the cathodic production engineer. He is also working in the corrosion engineering doctoral. So his nature of duty to control the cathodic reactions by means of earthing. Some cathodic absorbing materials or say as a magnesium is one of the very good absorber for the cathodic and anodic reactions. It will absorb. For highly corrosive environment of the equipments, instead of it will be protected by means of a block which is attached over a surface of the equipments. When contact with the process plate, the equipment component is stopped from the corrosion and the magnesium block will receive the anodic reactions. It consumes the anode, the anode of result, the magnesium block will be reduced. How much of the magnesium block consumed, that is effective result is given for the equipment to protect from the environmental, hydrogen environmental corrosions. That may be a cathodic production or maybe a anodic productions. Whatever, any kinds of the highly environmental, the pH value, if it is higher than 4 or 5 maximum, it will be a very hydrogen environmental potential for the corrosion factors is involving to reduce the by means of the corrosion engineering doctor by using cathodic productions. So the hydrogen environmental, you can see that the anodic reactions and the cathodic reactions, how the equipments affected from the ion. You can see the environmental first contact with the atmosphere, hydrogen from the atmospheric air is received by means of a ferrous, and then ferrous oxide, it emits the anode and electrons by means of a ferrous ion. The ferrous oxide is one of the mechanism for the wet corrosion. Oxygen absorption, that is, it may be hydrogen or sodium or sulfur, chlorine. So different corrosive fluid service depend upon. Supposed to be the ion is react with the chlorine, then ferric chloride will be also a very dangerous factor to here consider for the corrosion service. The cathodic production, so sodium hydroxide, sulfur hydroxide, hydrogen sulfide H2S, that is also a very harmful and killer gas produced from the equipment, create a high corrosive environment. That can be also controlled by means of a corrosion engineering doctoral. So the purpose of the class, what is the nature, what is the quality of the engineer, how the engineer involved, like as a doctor to treat the patients, how the doctors involved to treat the patients. Similarly, the equipments, how it will be protected by means of a engineer. So now the engineer seemed to be as a doctor. He is a corrosion engineering doctoral. You can see here how the anode area caused by the cracking, the pitting corrosions, successive pitting corrosions merged by the ferrous oxide. Sodium chloride is also one of the aqueous solutions active on side. Ferrous is the composition of the material. Say as here you can consider 516 grade A or B or C. That is as per the STM. 516 carbon steel material. Now the carbon steel material react with the chemical reactions with chlorine and pitting corrosion. Ferrous chloride form the pitting corrosion create a puncture. Now the puncture, a hole is formed, that is due to rust. The surface is covered by the rust. If you break the rust or remove the rust, after removing layer by layer, there is a puncture inside the wall. So that is a very highly danger when the process fluid is easy to oozing out or leak out from the surface. So that can be very quickly, very effectively controlled by means of your corrosion engineering doctrine. So different types of corrosions are controlled by means of your corrosion engineering doctrine. Usually general corrosion, pitting corrosion, greaves corrosion, intergranular corrosions. Intergranular corrosions, that is the HIC, hydrogen induced cracking, stress corrosion cracking, erosion corrosion, combination of erosion, corrosion. Corrosion usually outside the surface of the equipment, erosion usually inside the surface of the equipment. So that is the simple logic information you can understand. The process fluid, wherever the contact with the surface of the equipment, that comes under erosion. Corrosion is usually comes contact with the atmospheric air or atmospheric nature of corrosive environment create a corrosion. So outside the wall of the equipment affected by corrosion, inside wall of the equipment is affected by means of erosion. Sometimes the equipment also affected combination of erosion corrosion and cavitation corrosion, corrosion fatigue, hydrogen blistering, that is called as the HIC, hydrogen induced crack. The blister, the metal will be blistered inside the surface of the, it will not be occurred outside, it will be occurred inside of the equipment and the surface of the wall. By visual inspection it can be observed metal blistering. If you are brokening the blisters, in nearby successive two blisters joined together by means of a intergranular, the crane structure of the material will be joined together, that is the hydrogen. Main factor, entrapment of hydrogen. The hydrogen entrap inside the stainless steel, say yes, then hydrogen blisters will occur. Hydrogen entered inside the ferrous, then hydrogen successive blisters will be made by means of a cracking form, that is the hydrogen induced crack. Hydrogen temperatures, that is also high temperature attack will be occurred. General corrosion, so you can see here in the pictures the atmosphere, air contact with the piping, the external surface affected with a moisture of air, oxygen involved with the ferrous and ferrous oxide will be developed. External exposed area of exposed surface of the equipment is affected. Now the property also losses. That is the general corrosion. Fitting corrosions, this is simple examples. Now here you can see the jug, the water will leaking from the bottom of the jug. You can see the pitting corrosion is developed and how deep the metal retaining thickness. The retaining thickness of the material is the nominal thickness. Apart from retaining thickness is the below the pitting thickness, that is the retaining thickness. Apart from now the pitting is penetrated, the wall will be open out and the water will be leak out from the mug. So that is the pitting corrosions. Pitting corrosion, these are all usually due to a continuous service without corrosion engineering. Continuous service of equipments without inspection, without maintenance. The maintenance is the only looking over external and mantling, dismantling, cleaning. That part of activities maintenance. Apart from cleaning, after the cleaning, how the condition of the equipment by visual inspection from and also by means of some NDT, a lot of NDT, basic entities there and advanced entities there. basic entity like as the PT, penetrant test, MPT, magnetic particle testing, UT, ultrasonic testing, and RT, radiographic testing. These are the some basic entity methods to mitigate the pitting corrosions. Observe and how much of the pitting is, whether it may be used for the continuous service of the equipment or it not be cannot use for the equipment for the certain durations. You can change the equipments or repair the portion where the locations affected by the pitting corrosion. The portions how to remove the portions or how to cut and replace by means of a help of a corrosion engineering persons is the corrosion engineering doctor. His advice is very highly effective to mitigate the measures. So the corrosive nature of equipment and atmospheric corrosions and some intergranular corrosions and process fluid also very. You can see here this is a intergranular corrosion, how the crack will be developed from the beginning. So the initiation very wide width of opening and very sharp edge of hairline cracks will be generated is a active corrosion. Some corrosion is called as a passive corrosion, some corrosion is called as a active corrosion. If it is active corrosion, now the corrosion is a active corrosion from the figure is a 500x of developed micro structural that is done by means of PMI, positive material identifications. That is one of the positive material identification to identify the material classification and metallography replica test. Result is the graph 500x replica test gives the structural deformations of the material, how the material degradations occurs from the location at where and begin and where at the end. So that can be joined by means of a intergranular, that is called as the hydrogen induced crack, kick, simply called as kick. Some stress, if it is act in this material, stress may be vibration. The equipments usually told us the static equipments and some equipments called as the rotating equipments. If it is static equipments, there is no any external stress will be occurred in this material. The equipment will be not affected by stress, external stresses. Suppose if it is a rotating equipment, say as a pump or turbine, then is a rotating equipment, some external stress will be act along with the corrosion, that is the stress corrosion cracking. The stress is also one of the factors involved along with the corrosion, that is called as HSC. So stress corrosion cracking. So different variety of corrosion, environmental natures, productive measures done by a engineering doctor, that is the major part by means applying a coating and wrapping. So how the corrosion is eliminated by a coating and wrapping. Wrapping is the isolation of material by insulation. Coating is the protective coating applied over the surface. That is also a corrosion engineering doctor done by a specialization of NACE persons. NACE. So that is are the functioning of corrosion engineering. Some design factors also helpful to remove the or eliminate the corrosions. Instead of orthogonal edges or stagnant area, we have to modify the design with a conical portion. So that is the surface, there is no stagnation of the fluid surface, that's why the corrosion is also, so the design is also done by means of a corrosion engineering doctoral. So these are the some corrosion components, how it will be affected. You see general corrosion, wall affected by means of a atmospheric condition, general corrosion, pitting corrosion, then galvanic corrosion, greaves corrosion. So these are the some types of corrosions on the material occurred. So, I am very glad to say for you that class will be little bit, we have to extend the class in the next sessions, very deep and informations.